Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at 6.5, solving trigonometric equations. So some strategies for solving these equations. Step one, probably your easiest one if you've got something that looks like 2 sine x is equal to 1, is isolate the trig ratio if possible. From there, other strategies include factoring and then setting each factor equal to 0. So factoring by taking out a greatest common factor, by difference of squares, using our trinomial factoring, which sometimes for the trinomial factoring, it might be easier for you to visualize if you replace your sine x's with just regular x's. You might find that easier. However, you would need to show your work with signs of x's. And then another strategy is simplify the given equation or change the given equation to one common ratio. So changing it all to sines or changing it all to cosines. By using one or more of our identities, we've used this unit. And then from there, solve however you need to. So what does that look like? So solve each equation algebraically over the domain 0 to 360. So in this, we're going to give all of our answers in degrees, remembering our favorite rules like our stripper rule. We've got our 30-60 triangles, and we've got our 45-degree triangles. Those are very important things. So looking here, well, I would say this one we're going to isolate. So divide by 2, we've got sine of x is equal to root of 3 over 2. So now we want to figure out what our reference angle is. Well, if I look on my triangles, well, the only triangle with a root of 3 and a 2 is my 30-60-90. And from I get an opposite over hypotenuse if I start at 60 degrees. So that means our reference angle is 60 degrees. Well, then we want to check, well, our value was positive. Well, sine is positive in quadrant 1 and quadrant 2. So that means x is equal to 60 degrees. And then my quadrant 2 angle would be 180 subtract 60, so 120 degrees. Our next one, cotangent plus 1 is equal to 0. I'm going to subtract 1 from both sides, and I'm going to get cotangent x is equal to negative 1. Well, we don't necessarily know our exact values in cotangents, but we know that tangent is the reciprocal of cotangent. So that means our tangent of x would be equal to negative 1. Reciprocal of negative 1 is negative 1. Well, on our special triangles, that would be an opposite over adjacent of 1 would give us a reference angle of 45 degrees. And then we want where tangent is negative. Well, tangent is negative in, so if we check, tangent is negative in quadrant 2 and quadrant 4. So that means 180 subtract 45 degrees and 360 subtract 45. Remembering we're always using our x-axis values as our starting point and then using our reference angle to either add or subtract. And so this gives us our x is equal to 135 degrees and 315 degrees. Example 2, solve each equation algebraically over the domain 0 to 2 pi. So this means all of our answers have to come in radians. I'm going to put up my special triangles again. I always write them at the top of my page. So this is 30, 60, 45. All right. Well, we've only got one sort of term here, so I'm going to add 1 to both sides and then divide everything by 4. So I've got sine of x. The sine squared of x is really sine x squared. Well, to get rid of our square root, we're going to take the square root of both sides. So this is sine of x is equal to plus or minus 1/2. Well, where sine is positive or negative is all of our quadrants. And where sine is equal to 1/2, we have a reference angle of pi over 6. It was 30 degrees, yeah, pi over 6. That's our reference angle. Well, so then my values would be pi over 6, that's my quadrant 1. My quadrant 2 would be 6 pi over 6, or pi, subtract pi over 6. So 5 pi over 6. I've got 6 pi over 6 plus pi over 6, so 7 pi over 6. And then our quadrant 4 would be 2 pi, which is 12 pi over 6, subtract pi over 6, which is 11 pi over 6. B, so cos of x plus 2 cos of x is equal to 0. Well, here I notice I've got a common factor. So I'm going to take out a cos of x, and I'm left with cos of x plus 2. And that's all equal to 0. Well, I've got my factors now. I can split and set each of my factors equal to 0. So cos of x is equal to 0, and cos of x is equal to negative 2. Well, right off the bat, cos of x is equal to negative 2. That does not exist. Cos of x is never equal to negative 2. We know from our basic cosine graph, that we start at 1, we end at negative 1. It's never negative 2 in a basic cos of x graph. Well, then where our cos of x is equal to 0, well, that's going to be one of our quadrantal angles. Well, cos, again, is our x-coordinate. Well, where our x-coordinate is 0 is at 90 and 270, which in radians is pi over 2 and 3 pi over 2. That means our final solution, pi over 2, 3 pi over 2. Cos x squared subtract 3 cos x subtract 1. Well, in this case, I would move the 1 to the other side. So we want to think what multiplies to be 2 adds to be negative 3. Well, that is negative 2 and negative 1. So 2 cos squared x subtract 2 cos of x subtract cos of x plus 1 is equal to 0. If we take out a common factor, we are left with cos of x subtract 1. If we take out a negative 1, we're left with cos of x subtract 1. If both of your factors match, you know you've done it right. So taking out our common factor of cos of x subtract 1, we're left with 2 cos of x subtract 1 is equal to 0. Well, now we're going to set each piece equal to 0. Cos of x subtract 1 is equal to 0, and 2 cos of x subtract 1 is equal to 0. So we get cos of x is equal to 1/2, and cos of x is equal to 1. Well, where we have our coses as 1, again, that's one of our quadrantal angles. Cos is our x, and that is right there. Things we want to check, though, is are we including 2 pi? Yes, we are. So if we're including 2 pi, this one has the solutions of 0 and 2 pi. Where cos is equal to 1/2, we've got 1, 2, root of 3. Well, a cos is going to happen at 60, which is pi over 3. We have a positive cos value, so we've got pi over 3. That's our quadrant 1. And we would have 2 pi subtract pi over 3. In order to add fractions, we need common denominators. So 6 pi over 3 subtract pi over 3 is 5 pi over 3. So then finally, we're going to write our final solution. So x is equal to, we typically start with our lowest and go in increasing order. That is the proper way to write that. Our next one, solve each one over the domain. Well, looking here, I would say we've got a sine squared is equal to tan x times cos. We've got 3 different identities. I would try and simplify. So sine squared x is equal to, well, tangent is really sine over cos times our cos. Well, our cos values are going to reduce. This means we have sine squared x is equal to sine of x. I would move our sine to the other side. take out a common factor. So now, set each piece equal to 0. We've got sine of x is equal to 0 and sine of x is equal to 1. Again, those are our sort of what I like to call quadrantal values. Here we've got 1, 0, (0, 1, (-1, 0, and 0, (-1. Well, where our sine value is 1 is at 0 and 2 pi. And where our sine, that's where sine is equal to 0. Nope. Sine is equal to 1. Sorry, sine is our y value. So where our sine is equal to 1 is at pi over 2. Where sine is equal to 0 is at 0, pi, and 2 pi, because we have 2 pi inclusive in this one. So then our final answer, x is equal to 0, pi over 2, pi, and 2 pi. Our next one, so cos of 2x is equal to root of 3 cos x subtract 1. Here I would probably use a double angle identity because we've got a double angle. Knowing that everything else has a cos, I would probably use the cosine one. So 2 cos squared x subtract 1 is equal to root of 3 times cos of x subtract 1. If I add 1 to both sides, my 1's cancel out, and that gives us 2 cos squared x subtract root of 3 cos of x is equal to 0. If we take out a cos of x, we're left with 2 cos of x subtract root of 3 is equal to 0. Set each of our pieces equal to 0. So cos of x is equal to 0. 2 cos x subtract root of 3 is equal to 0. So where cos of x is 0, cos is our x-coordinate. Our x-coordinate is at 0 at pi over 2 and 3 pi over 2. Here, if we add root of 3 and then divide by 2, we get cos of x is equal to root of 3 over 2. We want cos to be positive. And if we look at our special triangles, we've got 1, 2, root of 3, where our cosine is root of 3 over 2 is at our 30 degrees, or pi over 6. So that means our reference angle is pi over 6. So then this one would be, quadrant 1 is a pi over 6. Quadrant 2 would be 12 pi over 6 subtract pi over 6, so 11 pi over 6. And then our final answer would be pi over 6, pi over 2, 3 pi over 2, and 11 pi over 6. Sine 2x plus sine x is equal to 0. This one, again, we've got a double angle. I would use our double angle identity. Well, at this point, sine of x is a common factor. We're left with 2 cos of x plus 1. Set each piece equal to 0. Sine of x is equal to 0. Cos of x is equal to negative 1/2. Where our y is 0 is at 0, pi, and 2 pi. Where cos is equal to 1/2. That's our 60, which is a pi over 3. And cosine is negative, so quadrant 2 and quadrant 3. Well, that piece is going to be, we've got 3 pi over 3 subtract pi over 3 and 3 pi over 3 plus pi over 3. So our final answer would be 0, 2 pi over 3, pi, 4 pi over 3, and 2 pi. And then our last example, so 6 sine squared is equal to cos of x plus 4. Well, okay, so again, we've got two different identities. We can't really take out a common factor. There's no way to actually factor it. So I would change one of them. Well, sine squared is really 1 subtract cos squared x. From there, we'd get 6 subtract 6 cos squared x is equal to cos x plus 4. If we set everything equal to 0, we get 6 cos squared x plus cos of x. And if we subtract 6, it would be subtract 2. So we want multiplies to be negative 12, adds to be 1. So that's going to be negative 4 and 3. So 6 cos squared x subtract, let's go plus 3 cos of x subtract 4 cos of x subtract 2. That way when we do our decomp, we've got nice common factors. We take out a 3 cos of x. We're left with 2 cos of x plus 1. If we take out a negative 2, we are left with 2 cos of x plus 1. And that's all equal to 0. Again, our factors match. We know we've done it right. So 2 cos of x plus 1 and 3 cos of x subtract 2 equal to 0. Take each piece, we split it. So cos of x is equal to negative 1/2. We've got cos of x is equal to positive 2/3. Well, cos of x is equal to 1/2. That happens at pi over 3. And then, so our pi over 3 and cos is negative. And then from there, we can also have our split the other side, set it equal to 0. We've done about 23 examples with this. This one here is not a special triangle value, so you would, in your calculator, go your inverse cos. Your calculator would be set to radians when you do this. And you should get your values.